Cool, thank you very much. So I've never given a talk right after dinner before. I hope everyone is sufficiently lubricated. I, on the other hand, am not, out of respect for all you beautiful people. But that means that after this, I'll probably be heading straight to the bar. So if you have any questions, then you can find me down at the bar. So I'll be talking about an NPM exploit that had happened last November. But first off, how many people have felt uncomfortable when presented with an instruction like this? Basically, you take something from the web and you run it through something else. You might even have people who jump on your keyboard and yell at you for doing something like that, or you might actually even be that person, or you might be motivated enough to actually put together a page on the internet to shame other people who do that. I mean, this is pretty common. It should feel uncomfortable because it's horrible and weird and icky. It causes really scary things to happen to your computer. Maybe, right? More often than not, it probably doesn't. But you still feel terrified about it. But as developers, if you are all developers, we're running random code from the internet all day, every day. Whenever we do a pip install something, or a gem install something, or an npm install anything, or brew install anything, we're just sucking in code, not auditing it, don't know where it comes, don't know what it's doing, we're just trusting that it's okay, and sometimes it's not. So last November, a very popular package was exploited and downloaded millions upon millions of times for a month and a half before anyone noticed anything. So first off, who am I? I'm a generic web dork. I've been talking about JavaScript and breaking web apps for a very long time. Director at Shape Security. If you are old enough to have played games like Fallout, StarCraft, or Total Annihilation and have broken any of those, then you might have used some of my tools to do that. So let me starting off with how it happened. It all started with a single package, event-stream. So event-stream is one of the earlier packages to have been created in the Node.js ecosystem based around the stream architecture. Streams are basic primitives in Node. They're very, very popular, kind of complex. So a tool like this built early on is going to become very, very popular very, very quickly. As of right now, it has over 1,500 direct dependents. Direct dependents of those projects certainly just spiral out of control. And has been downloaded or is downloaded 1.2 million times every single week. Event-stream was maintained by prolific developer Dominic Tarr. This is not a no-name sort of guy. This is a very, very popular person in the Node.js and elsewhere ecosystems. He is very, very active. He has quite a following on GitHub and otherwise, and has a lot of code to his name. Hundreds upon hundreds of repositories, hundreds of modules in the Node.js world. And he's not just a random guy who doesn't know how to develop good software. But on one day in September last year, he gave the control of that repository to some random user on the internet, Write9 control. Now you might ask, why would somebody do that? The whole point of some of these people trying to put together an open source persona is to have the chance of maybe having a project take off so they can tie their name to it and then have that be a brand building exercise later down in their life. Why would this guy give up something like that to just some random person? Well, he answered that for us. He emailed me and said he wanted to maintain the module, so I gave it to him. And I can't really blame him. He's not getting paid. Might be fun at the start to build some of these projects, but at the end of the day, after a couple years, you just have people whining at you to do work for free, and it ends up being kind of a pain in the ass. And this is not unique to Dominic. This is prevalent all across open source. And this is what we're building up on top of right now. A lot of people and projects who just don't want to work on their stuff anymore. And that's okay. Just because you release something once doesn't necessarily mean you want to maintain it till the end of time. Anyway, Write9 control gained trust by committing several innocent changes. Updating dependencies, it was a project that hadn't been worked on in a while, added some examples, updated some documentation. It was pretty basic stuff. On September 9th, Write9 control added a new dependency and released version 3.3.6. The dependency was flatmap-stream version 0.1.0. This dependency had nothing weird about it. It did something useful. It didn't look like anything was strange. But let's talk about that carrot. So first off, a quick run through on semantic versioning for anyone who's not up to speed with semantic versioning. Semantic versioning is those three numbers separated by two dots, blank dot blank dot blank. It goes major, minor, patch. So as you add bug fixes and patches, you increment the patch version. Add features, you update the middle version, the minor version. And as you break APIs, you update the major version. The thought there is that they are increasing in risk with those numbers so that you can get a better understanding of what you're updating to. So in Node and some other languages, or in NPM rather, and some other dependency managers, there's this concept of pattern matching with semantic versioning. So there's a tilde and a caret that'll match a range of versions so that you can basically say, I'm okay with automatically updating to versions that adhere to this sort of risk. So with a tilde, you're taking in bug patches and fixes and things like that. With the caret, you're taking in minor features and bug patches. It's a convenience thing, but I think as we've learned in security, every time you add convenience, you take away all this other stuff that we grow to love and enjoy. And as an example, so for package 2.0.0, generic package, depending on generic dependency 1.1.2, so let's say package 2.0.0 doesn't change. But over the course of its life, you've had other dependencies get published, 1.1.3, 1.2.0, 1.2.1, 2.0.0. Now the next time package 2.0.0 is installed, it'll automatically pull down package dependency 1.2.1. That's because of this caret up here. It'll match the latest version of the latest one that matches minor and patch version. So that'll be 1.2.1 in this example. So after adding flatmap-stream in 3.3.6, right9 control then removed flatmap-stream and then published 4.0.0. So notable so far, nothing malicious has emerged. So what we had is just a normal guy updating some dependencies, updating some documents, adding a dependency, exposing it as the API, taking away that dependency. Maybe it didn't work out, maybe it wasn't valuable, updating the major version because the API broke. All normal stuff so far. The total time between first commit and version 4.0.0 was 12 days. So on October 5th, 2018, this is 31 days after ownership of EventStream has changed control, flatmap-stream 0.1.1 was released. This is a package that has malicious code in it. Now, because EventStream 3.3.6 had the caret in its dependency definition, it would automatically update to 0.1.1 because of that caret. EventStream itself had been stable for 2+ years. So that means that everyone who had installed it automatically added dependency 3.3.5, probably with a caret or a tilde, so that every time any of those got installed again anywhere, either a new developer pulling it down, somebody blowing away the dependencies, reinstalling them on a build machine, whatever else, it would automatically suck in that malicious dependency. And this happened 8 million times over the course of about 5 or 6 weeks. So the time between the malicious control and the discovery of this, 77 days. And the time between flatmap-stream 0.1.1 and it being exposed was 48 days. So 48 days in the wild being able to affect whenever it wanted to infect. And as you can imagine, most developers are supremely confident people with supremely privileged computers in companies that have all sorts of fun things inside them. And this is where this code is running. So, what it did. First off, I want to talk a little bit about how it was discovered. And you'll all be glad to know that it was just pure dumb luck and coincidence. So Payload A, we'll talk about in just a second, used a method that was deprecated in Node version 11. It was deprecated by documentation in version 10. Once version 11 was released, it was deprecated at runtime, which just meant that a warning was issued. Node 11 happened to be released 18 days after the exploit was published. So just by pure dumb coincidence, now we had unrelated projects throwing a warning. So things like NodeMon, which is a very, very popular way to run long-lived Node.js processes, started to get warnings based off of the crypto package in Node. Now, when you have a project that shouldn't be doing anything with crypto packages and starts throwing errors or warnings about crypto packages, it starts to raise some red flags. Finally, somebody started putting this all together November 20th, 2018. Falling snow basically opened up an issue on event stream. In many, many words, or basically just asking what the fuck. What's going on? There's something very, very strange and odd going on, blaming Dominic, blaming Right9 Control, wondering why this malicious dependency was then backed out without anyone knowing. It then caused the entire community to stir up, and then everyone started to get on this to figure out what was going on. So, flatmap-stream version 0.10 looked like this. And for those of you who are unfamiliar with the JavaScript ecosystem, it's okay. This should look stupid. It's a bunch of code smashed up together. That's normal in JavaScript world. I'm sorry. It's just the way things are due to the way things have evolved. But that's also, it's one more problem in the JavaScript ecosystem because it's one more strange artifact in the way between source and distributable. So this is flatmap-stream version 0.11, just 352 bytes appended to the end of legitimate flatmap-stream 0.10. So this is the source prettified. I don't expect you to jump too deep into it right now. This is the source flattened a little bit with some things renamed to make it easier to actually walk through. First off, we've got an unhex function at the start, which does what you probably would expect it to do. It just translates a hexadecimal string into a string that you can read and understand very easily. And the first thing that is actually happening there, or the first thing that is actually, first operation that is executed, is an unhex of this string right there. Because we're not too worried about what's going on right there, we can do that by hand. And then find out that we are importing another JavaScript file, test data. This was a file that was distributed with flatmap-stream 0.11. Go over to check that out. It's a bunch of other hexadecimal strings. The first two are very, very long. When you try to unhex them, you just get a binary blob of data. It's not very useful yet. But the other ones end up unhexing to readable strings. Yeah, crypto, env, npm package description, AES 256, create decipher. A lot of things that start to look a little shady, which is exactly why somebody would hide this in another file and behind something all hexified. It's not very difficult obfuscation, but what you're trying to do here is just prevent those people who are just taking a cursory glance from getting all worked up. So next right here, I've replaced all the references to those hex strings and renamed some variables so we can go through this line by line. So the first line here is us importing that test data. It's being thrown here in a variable called test data, because why not? Next couple lines here. We're getting an environment variable called npm_package_description, and we are using that variable as the key to a decipher instance that we're going to be using later. So we're pulling the key from the environment. We'll have to deal with that in a little bit, but we'll go through line by line right now to understand what's actually happening next. So the next step is here, we are decrypting the data that was found in the first element of that test data. Finally, down here, we are creating a new instance of a nodejs module. You can ignore the past thing, it's irrelevant really. And then we're compiling the decrypted text. And then, so that will create a JavaScript module in Node that has logic associated with it. And then that module will be exporting the second element in our test data. So now back to where we're getting the key. So we're getting this from the environment, and this requires us to dive into a little bit about how NPM works. So NPM is three things. NPM Inc. is a company. NPM, the registry, is a registry of NPM packages. And then there's NPM, which is a command line interface, which is just a tool that can pull from any registry. So NPM is a dependency manager, but it's also a task runner. And you can define tasks, well, you define everything that NPM needs to deal with in a package.json file. If you've ever seen those floating around, they're freaking everywhere now. It started because of this. So this is a completely separate package.json. I'm using it as an example. So the scripts are defined something like this. You just have a property in JSON, and then you have a list of tasks essentially that you want to run with the commands that you want to run with that task, whenever that task is invoked. So what we're looking for in that environment is this description. Because when we are running an NPM script with NPM, it'll take everything that's in a package JSON and throw it into the environment so you can store data in your package JSON for access later in NPM scripts. So we know now that this script needs to be run as an NPM script in order to find that key. So a recap. The script decrypts and compiles a new module in Node. The key comes from a package description in a package JSON somewhere. The encrypted JavaScript for the new module comes from the first element in the test data, and the compiled module then exports the second element in that data. So what does this mean? The script only is useful if it is being run as an NPM script inside a directory that has a package JSON that has a key in the description that successfully decrypts the test data we have, which means that this is a very, very complex, comprehensive exploit that is targeting one single package on the internet. So what this means for us, if we want to dig any further, is that we have to troll through a lot of NPM packages. Well, we need to troll through a lot of package.json files. The largest consolidated source of package.json files is the NPM registry. There's no guarantee that it's going to exist there, but it's certainly a good place to start. So now what would we want to use if we needed to troll through all of the packages in the NPM registry? Luckily, there's an NPM package called all the packages, which allows you to take as a stream all the metadata for all the packages that exist in the registry. And yes, of course, that depends on event stream. So you'll probably want to be doing things like this in a virtual machine or some sort of environment that's not your home machine. This is how JavaScript has evolved, and just everything depends on everything else, and everything's horrible. So the strategy here, iterate through every single package that exists. Try to decrypt the test data. Because some keys can successfully decrypt the data but result in garbled gibberish, we're going to want to pass that decrypted data through to a JavaScript parser to make sure that it parses as actual JavaScript, just so we don't have to deal with a lot of visual handling. And then if we are successful, then we have a winner. This is one of those long shots that I didn't expect it to work. It worked so quickly that I was just like, fantastic, this is beautiful. In 94 seconds, we had gone through every single package in the NPM registry, tested all those things, found out what decrypted, and found out exactly what we're working with. It actually happened much faster than 94 seconds. I just went through everything to see if there were other packages, but it worked. And the password was a secure Bitcoin wallet from the package Copay --. Copay, for anyone who's up to speed on crypto, is a secure Bitcoin wallet where you can store your Bitcoins and protect them from hackers. So now we know our target, and now we can decrypt our Payload B. So Payload B does a little bit more. We're not going to go in through it line by line. We're going to focus on a couple. So starts here. One thing to note is whatever this is, we'll get to in a second, if that is false, then we're just bailing out. So this is even further targeted. We're targeting a specific package, and now depending on this condition right here, we're also bailing out if it's not exactly right. Now what we're actually looking for here is we're testing a regex against arguments passed on the command line, argv. So if you're not entirely familiar with how NPM scripts run, because we know that we are running in an NPM script, we know what the third our element in argv is going to be, because we know the first one is NPM, we know the second one is run script, so the third one must be the actual script that is being run. And there is a circle. So what we're looking for in Copay - is a script that starts out with build, blah, ends in -release. This is all just falling into place so well. It was such a beautiful day's worth of reverse engineering, because it very rarely happens that everything just works out. So you have access to this entire Bitcoin wallet because it's open source, and everything is there for you to see. So you have build, iOS release, Android release, and desktop release. So this payload only continues if it is being run as one of these scripts. Now, if you're familiar at all with the web world over the course of the past 5 to 10 years, Cordova might be familiar to you. If it's not, then maybe PhoneGap is. It's a hybrid web native framework. So you can use JavaScript, HTML, CSS, whatever else, and then deploy native applications to Android, iOS, desktop, whatever else. It's the precursor to things like Electron right now, which power Visual Studio Code, Slack, Skype, things like that. So we know we're running in these scripts. We know that we're targeting a Cordova hybrid build, so we can look more into Payload B. The only other thing I want to point out right here is this line right here. So in the node world, all your dependencies in a project are stored in a node_modules directory. So what this is doing is, first of all, just pointing to some deep dependency that exists. And the gist of what's happening here is that this payload is diving deep into the dependencies for Copay Dash, the mobile application, and then appending its payload C to one of its files that it know will be hydrated and executed in the context it needs to be executed in the mobile application on a user device. All right, recap. So Payload B doesn't do anything unless it is in Copay's build stage, building on iOS, Android, or desktop application. It decrypts Payload C just like it does Payload B. It injects Payload C into a dependency that Copay will eventually use. And then Payload C is executed in the context of the mobile application on a mobile user's device. This is Payload C, which actually keeps on going down a little bit there. It's actually not very exciting. This is the last payload. And when situations like this, the last payload is just doing what you wanted to do in the first place. The fun ones are the middle payloads that figure out how to get to that part at the end. It's just a bunch of web stuff, dealing with documents and local storage and stuff like that. The gist of it is it was harvesting private keys, targeting wallets that had 100 Bitcoin or 1,000 Bitcoin cash, sending that stuff off to a third-party server, like really just generic Bitcoin crap. I was really kind of disappointed. Everything seems Bitcoiny now. You get a miner, you get Bitcoin stolen, you get ransomware asking for Bitcoin. Where's the creativity? So, where does this leave us now? First off, this is not Node and NPM specific. This can happen anywhere that public source can be distributed. Node and NPM are just incredibly popular right now, so it's an easy first target. There's also no reason to assume that this isn't currently happening now. This was found by accident and coincidence, and that's it. If it was never found, if that deprecated method was never released in Node version 11, who knows when it would have been found? So the good news is that once it was found, the community really came together. They responded quickly, found the depths that it went to, investigated everything collaboratively and independently, had people backing each other up, helping each other. It was the further damage going forward was mitigated. NPM stepped in, took over that package, made sure that it was addressed there. And then people were building tools that would help each other figure out whether or not they had that problem and whether or not they were infected. The bad news is that virtually nothing else happened. Everyone just patted themselves on the back and went on with their lives, and that is the extent of really what has happened. This could have been much worse. Event Stream was depended on by so much. The Azure command line interface, Azure, Microsoft's cloud platform. Anyone who deployed anything to Azure with Azure CLI could have been infected. People developing Azure CLI could have been infected. Dozens of web build tools, Gulp, Browserify, Webpack, all these things depended on things that depended on Event Stream. Now, all those tools are used to build websites all over the world and can easily be targeted just like this. Microsoft's Monaco editor, the editor used in Visual Studio Code, used Event Stream. Visual Studio Code doesn't even necessarily affect just Node people. Anyone who uses Visual Studio Code could have been infected with something. The reach was wild, and I have to imagine that like the beauty in putting all this together was wasted on this stupid little Bitcoin application. And I have to imagine that the person who did this they had a target at the start, and they went towards that target without recognizing the amazing potential that they had in front of them. Anyway, this is a security audience. I'm not fully expecting that any of this is going to be wildly new to any of you, but audit your dependencies. Don't trust anything. Lock your dependencies if you're using a dependency manager that can lock them so you don't actually have things updating without you knowing. Check in your dependencies because there's really no need to continually download them. If you're expecting to use a particular version, retain that version internally. And sure as hell, think twice before adding any new dependencies. The JavaScript world likes to have modules for just about everything, and every module that you depend on is one more little bit of risk that you add to your project. All right, thank you.